And we're live. Hi.
Hi, Nicholas. This is Nathan Brookwood. I'm the founder, principal analyst, and research fellow, a lot of big long title, at Insight 64, where for the last 22 years, I've been following the semiconductor industry with a little bit of a focus on processors, but I actually look at platforms and systems as well. So I have a pretty broad range of things that I'm trying to follow because I get bored easily.
But there's so much stuff happening in this industry, no? And there's so many like huge stories. I think like Huawei, and that's a huge thing. And the U.S. is trying to get the sovereignty back with making the chipsets in the U.S. Do you think that's not like a piece of cake? How are they going to
No,
even try to do that?
I think that's a lost cause, actually. Um, Intel, of course, still maintains pretty close to state-of-the-art fabs in the U.S. Global Foundries has a large fab in the U.S., but they gave up on trying to pursue the really state-of-the-art 5 nanometer, 3 nanometer, and so forth. They're really focusing on niche markets, and so there isn't much of an infrastructure other than for Intel supporting semiconductor manufacturing in the U.S. And these fabs are now costing close to $10 billion to put up. So when somebody says, "Here, take $20 billion and give me an infrastructure," they're not going to get much of an infrastructure with that. And I think at this point, it really makes more sense for us to make sure that the supply channels, the supply chains are clear and that we have the right relationships, particularly with TSMC and Samsung, because I don't see an easy way for the U.S. to catch up.
TSMC is like as a monster, is huge, right?
It's huge, and they grow up a new fab in about 12 months from groundbreaking to production. Intel takes 24 to 30 months to do that, and so for TSMC, they have focused strictly on semiconductor manufacturing. They've got a good name for that, right? And they are, in semiconductors, volume is everything. If you have the highest volume production, that means you're going to have the lowest costs and you're going to be able to improve and go to the next process technology faster than your competitors. And if you go back 10 years ago, before smartphones were really a big thing, Intel had the largest manufacturing volume. And that gave them the ability to lead in terms of process technology. Nowadays, TSMC, because of their relationship with companies like Apple and Qualcomm, has much greater volumes than Intel, and that gives them the ability to bring up a new process every year. The iPhone, the chips that TSMC makes for iPhones and tablets are on 5 nanometer now, and that's awesome technology. It's going to be pretty hard for anybody to catch up with them. It's especially hard right now because the industry is undergoing a transition in terms of the lithography technology they use for the smallest features, going to something we call extreme ultraviolet, which helps in getting 5 nanometer transistors placed on the chips. And they've now been doing that for over a year with some of their processes. Samsung is using EUV for some of its most precise imaging. And Intel has a bunch of these devices that are in a development lab in Oregon, but aren't being used for high volume production. And until you get into high volume production, it's really hard to make sure that what you're doing works. So given that TSMC is so far ahead of Intel. I find it problematic or challenging, I guess is a better word, that Intel is going to be able to catch up.
There's even a story that's I think is interesting is that the EU is in talks, and also the EU is panicking a little bit and saying, "Hey, everybody's like going into all these trade wars over the last 4 or 5 years and blocking who gets chips and who gets what." You know, like Taiwan is not really supposed to be part of China, right? But I would think that China has some kind of influence in terms of telling them what to do. Also, they shouldn't just supply the Americans when the Americans are blocking the Chinese, something like that.
Well, I think that all of these geopolitical considerations are becoming more and more worrisome. When China took over Hong Kong back in '97, they very proudly proclaimed one country, two systems, to cover the fact that they were going to keep the democracy aspects in Hong Kong going. But we've seen how they've been clamping down a little bit on that over the last 5 years, and that's worrisome. And they also, China, the mainland, PRC, still thinks that Taiwan is part of China. And at some point, there may be some sort of clash. On the other hand, the Chinese are very practical, and they would not, I think, if they did intervene in Taiwan, want to kill the goose that's laying the golden eggs or the golden chips. And so that would probably continue on pretty much undisturbed.
When I look here, it even shows that Intel is panicking that they're trying to get TSMC and Samsung to make some of their chips because maybe even Intel has some issues delivering to capacity.
Intel's been struggling with the most advanced semiconductor technologies, and this is no secret. They were supposed to be on their 10 nanometer about 3 years ago. They're still not really there in volume. And in fact, they have taken some of the chips that they had designed using their 10 nanometer design rules and backported them to work on 14 nanometer processes. And when you do that, you give up the advantages of smaller, denser transistors. And so that makes Intel less competitive. And I think we're going to see that more and more over the next year or two, because AMD, who threw in their lot with TSMC 3 years ago, now has a real process technology advantage over Intel. And, there's, Pat Gelsinger, Intel made a change in CEOs. They brought back Pat Gelsinger, who is clearly a very smart technical guy and an astute business person at this point after his seasoning at VMware. And we'll see what he can do. But it's not just the guy at the top, it's the whole infrastructure inside the company in terms of the technical talent in both design and manufacturing, lots of which has flowed out of Intel over the last few years. And so Gelsinger is going to have to do a lot of rebuilding in order to get Intel back into shape.
So here's, it says, Intel's new CEO says troubled chip project is recovering. There's a lot of articles about this new CEO. A lot of things to say. Do you mind trying to click next to the mute button, the little arrow, and then turn off auto adjust mic volume? Turn it off.
Auto adjust.
Yeah, turn it off. Yeah, because I think it's going up and down on your volume.
Okay. How's that?
Yeah. Okay, that's good now. I think you're in a fixed volume and it's not going to mess around with it.
What about echo cancellation? Is that
you can keep that on. That's good.
Okay.
Okay. So yeah. So what do you think about this news? Intel CEO.
Gelsing, excuse me, Gelsinger's the right guy at the right time. Um, it was really a shame when he left Intel, but having been out of the company, I think he has a lot of regard inside the company. The employees like him, and having been outside, he now understands a little bit more about the challenges Intel faces competitively. You know, when you've been in the company as Pat was for 20 years before he left, you sort of, get into the groupthink about how Intel is, the only company and nobody else can do anything right. Now that he's been outside for 5 years, I think he sees that there are a lot of other people who are doing some very clever things. And so he can now, when he repositions the company, I think it will become more competitive. But it's going to take a very long time. And as I said, I'm not sure that Intel trying to rebuild its manufacturing chops is the right thing. If I was in charge, that would be scary. If I was in charge, I would seriously try to find a way to unload the manufacturing capacity to some other third party or sell it off to people who need those tools and rely entirely on TSMC, maybe a little bit on Samsung, rather than trying to do it in-house.
Because they've had issues getting down to the 10 nanometer. They've delayed it for 3, 4, 5 years. And then it's hopeless for them to get to 7 nanometer?
Well, I don't know that it's hopeless, but it's certainly challenging. And meanwhile, every year, TSMC moves the bar a little higher. And that's going to make it harder and harder for Intel to catch up. And that's why I just don't think it's a good idea to try. I am reminded of what happened to Intel in the mid-1980s when they still had a lot of their business relying on the sale of memory chips. And the microprocessor had started to take off, but it still wasn't really couldn't support the company by itself. And Andy Grove and Bob Noyce looked at their strategic situation. They concluded that they couldn't compete with the Japanese in terms of memory production. And they decided to get out and put all of their efforts into microprocessors. Now looking back, that was a very wise decision, although at the time it seemed kind of gutsy because, there was a whole division that was making memory chips who wasn't to be needed any longer. And I think channeling Andy Grove, if he came back today, he would look at Intel's situation and say, hey, why are we knocking our heads against this manufacturing wall? The game is no longer about manufacturing. The game is about designing and being innovative in terms of design. And we know how to do that pretty well. So why don't we just get rid of this boat anchor called manufacturing, go to TSMC, and become more competitive in terms of our products. That was something AMD did, and I think it's a path that Intel could follow.
I would think that you quoted as an analyst source in this article talking about the M1 Mac. Maybe the issue is that they keep trying to do x86. They should just give it up. Maybe it's easier to do a 10, 7, 5 nanometer when it's ARM because it's a more simple architecture to fab.
I don't buy that at all. An ARM chip today, if you look at what Apple is including in the M1 or any of the larger ARM chips, even some of the larger ARM server chips, that are coming out from people like Ampere. Those are very complicated chips. And the fact that it's an x86 versus an ARM has very little impact in terms of the ability to manufacture it. And that's why, for example, TSMC can manufacture in the same factory probably ARM-based chips for Apple and x86-based chips for AMD. So it's not so much the instruction set architecture that makes it hard. It's all the other things that you need to do in a modern semiconductor foundry, being able to handle the analog components of a chip, the digital components, large integrated memories, and so forth. That's what makes these chips hard. And the fact that it's x86 or ARM is really a detail at that level.
So the best in the world are TSMC and Samsung. How about Global Foundries? What's up with them?
Well, Global Foundries decided about 3 or 4 years ago that it was too expensive to try and maintain their position on the leading edge with regard to semiconductor process nodes. And, you know, they were playing with EUV, they were working on, you know, smaller transistors and so forth, but they just didn't have the volume that a TSMC or Samsung would have. And therefore, they decided to abandon the pursuit for leading edge technology in terms of geometries and focus instead on things where they felt there was a good market and where somebody who could deliver consistent quality for customers who didn't need that leading edge would be able to succeed commercially. And they therefore pursued their silicon on insulator technologies, SOI, and some of the other niche markets, communications being a big one, where the process geometries were not so crucial. And they've been able to make a business out of that and compete effectively, really, with companies like TSMC in those sections of the market. And they've done that with much lower investment requirements for tooling.
But I mean, in the beginning of our video, we were talking about Joe Biden and his issues and EU and their issues. But don't Samsung have really, really good fab right now in Texas? Is that where they're making all their 5 nanometer stuff right now?
Actually, Samsung is making most of the 5 nanometer stuff in Korea. The fab in Texas is focused primarily, I think, on digital logic, which is the SoCs that they make for smartphones and such. But they have, must be more than half a dozen fabs scattered around the Seoul area that are also on leading geometries, both for memories and for system on chip and microprocessors. So Samsung has diversified a little bit in that regard, but they're still heavily concentrated in Korea.
So we, the whole world, the planet, all the humans are at the mercy of Taiwan and Korea. Or is that what's happening? Or like if the China gets angry, they can start blocking what comes from TSMC?
I hate to think that that could come to pass, but if it did come to pass, I don't know that we'd have a lot of capability to resist it.
I mean, all these talks, all these articles they're hot air, what do you call it? Like it's not going to happen. There's no chance that they're going to make cutting edge fabs in the US and Europe.
Yeah, I think that's a bet I'd be willing to take. I don't know if Joe Biden is willing to take it, but I just don't see how the U.S. can rebuild an infrastructure for leading edge process technology. It sounds very defeatist. I'm sorry.
Yeah. I saw your comment on LinkedIn where somebody was talking about the chipset supply shortages, and you said, "Hey, but isn't that like just planned out years ahead? And why is somebody skipping the line, or what's happening? Why?" Or they didn't know they needed so many, and that they only placed the order recently. That's why they're not getting them, right?
That's my view. I know another analyst commented that he still thought it was helpful to be on TSMC's good side. But my understanding of the way TSMC works is you go to them and you say, we're going to need so many wafers, so many thousands of wafers per month on a particular process node, starting in June of X year. And TSMC, based on those forecasts, which are backed up in many cases by deposits, then goes and makes sure that they have the capacity in place to deliver. And TSMC, in many cases, will then go and put up another fab in Science Park or whatever, so that they can meet those kind of requirements. And if you don't forecast accurately, if you under forecast your needs, you may very well find yourself not being able to get all the wafers that you want when demand picks up and it's over what you forecasted. That's sort of the way a system like this should work. Just as when you had the manufacturing capabilities in-house, then you would plan to have the right amount of capacity in your factory. And if for any reason you didn't have the right capacity, then you wouldn't be able to deliver as much product as maybe your customers wanted. And in fact, that's happening with Intel. Intel's had some product shortages over the last year because they didn't have the capacity in place, primarily because they still never got to the 10 nanometer. And so they needed to make more stuff on 14. And that created Intel chip shortages, which created more opportunities for AMD. But AMD couldn't get the wafers either from TSMC. And so people were then fighting over the chips, either for GPUs or CPUs. And you've seen that the actual price erosion for many of those products has slowed. People are now willing to pay a list price in some cases, whereas before they needed or demanded and often got tremendously steep discounts. So in this, and again, hey, markets are supposed to work this way, right? When there are shortages, prices go up, or in the case of semiconductors, they don't go down as fast. And then, eventually capacity is added. People change their forecasts. TSMC goes and builds another factory, and all of a sudden we have an overflow, and then prices come down.
So here it says on this article, Anshul Sag is talking about the 37 billion down payment. It's just a down payment, and it's not going to be enough.
That's right.
But what I'm thinking is, okay, 37 billion. It's a bunch of money, but doesn't it take years and years and years to get anything done in this? It's not even going to be done by the first term of Joe Biden.
No, definitely not. Definitely not. And maybe we'll nationalize the semiconductor industry and the government will buy these fabs from Intel. I don't know.
I think that's a good idea. That would be nice.
Yeah, for Intel, let's assume they wanted to take my advice and get out of manufacturing. Then the question is, who's going to buy those factories? And what are they going to do with them? And, not easy to convert a fab that Intel built, and they all look exactly the same. Every Intel fab on the inside is exactly the same as all the others. That's as a result of a philosophy they've had for decades called copy exactly. But then to change an Intel fab to a TSMC fab would be a challenge because things are not laid out the same way. The flows are probably different. Some of the individual tools they use are different, and therefore it would be complicated to do. Now, maybe if you knew you were going to be converting the fabs in Israel and the fab in Ireland and the fab in Oregon and the fab in Arizona, then you might come up with a way to do that if, say, TSMC wanted to take those over and operate them jointly with Intel or whatever.
You remember this video we did a few years ago?
I do, yes. Back in the days when we had real meetings with real people and real.
Yeah, that was in a pre Noah's Ark work. What's it called? The thing we're doing right now. But what about the topic of that video? And it got 12,000 views. Was that Intel was going to make 14 nanometer ARM processors? It was basically those Altera FPGAs at that time. So I've always thought Intel's main mistake over the last 15, 20 years is that they only like play around on the side with ARM. They don't get big. They don't put their logo on the very big performance, the top level. They should put their logo on 5 nanometer ARM processors and provide them as an alternative to the M1, to the MacBook M1, right? And give all these Windows laptop makers an alternative to Qualcomm.
Well, first of all, they'd have to have a functioning 5 nanometer process, and they're a long way from that. Secondly, it's not clear that Intel can be successful selling non-x86 processors. I've always said that the criteria for success of a product line at Intel is that it has to be x86 compatible. That's a sort of necessary but not sufficient requirement. And then it also has to be able to compete in the marketplace against all the other available options, including ARM, including AMD, including, in some cases, PowerPC. And every time Intel has strayed from the x86 at the base of the product line, it's gotten its hand caught in the ringer. Titanium back in the 90s and aughts, they had strong arm that they acquired from Digital Equipment and couldn't figure out how to make that product line successful. What else? They've played with alternate architectures, the 960s, the 860s, and so forth. None of those achieved anything like the success or even the sustainability in terms of ongoing sales covering the cost of development that their x86 franchise has generated. And that's made it very hard for them to break out of that category. The image we have here in the background is actually I think it was an ARM processor that Intel was doing in partnership with Rockchip a few years ago. Yeah. There was a strange project they had going on. But if I get to your right here, there's another huge thing happening. Giant $32 billion or $40 billion story that the Americans were going to take over the ARM processors. I hope you're still connected. I saw you. I'm still connected. Yeah. Oh, that's the video.
Yeah. So your image kind of froze. Maybe can you click on stop video and start video again? Right there. You see it? Yeah. Hopefully I can get you. I'll just try to do like this. Okay, hopefully you'll be back, but I can hear you, right?
Okay, I can
Yeah.
hear you.
Maybe you can change the resolution to try the 720p or down to 360p. I'm not sure why the camera is not coming through. Potentially.
Let's try 360.
Yeah.
Here's 360.
Oh, there you are. Okay, cool. Okay, so this NVIDIA, ARM. My website is called armdevices.net. Your company is Insight 64, so it means 64-bit ARM, right? No, I'm joking a little bit, but there's the ARM is like so huge. It's insane how many billions and billions of ARM processors are just shipping daily, or not daily, but it's like huge.
400 ARM-based chips a second is the latest statistic I saw in terms, I think, from ARM. ARM releases that number every once in a while. And I remember 3 or 4 years ago, it was 60 ARM chips a second, which they refer to as 60 hertz.
Yeah.
And now it's 400 a second.
But there was this thing that happened the week after Brexit, which I thought was hilarious, funny or weird. Right there, they vote Brexit, the British, and then Japan, SoftBank comes in and buys ARM at a discount, kind of, because the British pound was hurt in that week or something like that. I don't know. It's like he kind of got 20% discount. I don't know if that's the reason or not, but I also think that the guys in ARM were thinking, "Oh my God, the whole thing is crashing. Let's get out of here," or something like that, because Brexit is a funny story also. But then now it's going over to maybe the Americans. The Silicon Valley is trying to buy the ARM.
Well, this is the NVIDIA ARM deal. Yes, another one where I've taken the position. Not that anybody pays attention to my positions, that it's a really bad idea. And I am if I was the European Commission or the Federal Trade Commission or Department of Justice, I would definitely not, or the Chinese people, all of whom have to sort of approve these kind of mega deals, I would say, not good, don't do it. And we'll see whether or not it actually goes through. And my logic there is really very simple-minded. ARM provides technology to a number of companies, hundreds, thousands of companies in the information technology arena. And I believe it needs to be, like Switzerland, a neutral party who can sell to any of those companies without compromising what they do or what their other customers do. And when they were based in the UK and they really didn't make any hard chips themselves, they just sold the IP to third parties. Everybody, more or less, had access to that technology, and nobody had to worry about, hey, are the ARM guys tilting a little bit more toward Qualcomm or toward Samsung or whomever, because they were not selling to anybody who competed directly with ARM. They were all customers. And if we have a situation where NVIDIA does acquire ARM, then if I was an ARM customer, I would be very skeptical that ARM was not telling NVIDIA what we were planning and allowing NVIDIA perhaps to counter that with their own product developments. And we talk about Chinese walls, but I don't think those Chinese walls are impermeable. So in my mind, ARM really needs to be owned by a neutral third party.
but as a European, I would have hoped that we would own the future. Like that we would control the what's called the destiny of everyone, and it would just be in our kind of like because Europe has so little. We don't have the Googles, we don't have the Amazons, we don't have Facebook, we don't have anything. We're just consumers of this stuff. But we actually invented Linux. We invented the ARM. We invented the web. Like all the stuff that everybody uses all the time, and it's worth so much. But it's like we're giving it away for free. And even the ARM chips have always been on a very affordable little few cents per chip. Like. I'm not saying it's not been profitable. It's been hugely profitable, but it's not like it's not like the Silicon Valley style business model. Like where you become multi-trillion-dollar companies.
Well, but when you look at it, if you're looking at it that way, Google gives away most of their stuff for free, and they've gotten pretty rich. So it's not an issue of ARM only getting a few pennies per chip. It's how many of those chips, and when they're going out at the rate of 400 a second, the pennies kind of start flowing in at a scary rate.
Yeah.
So there are lots of different business models, and from my perspective, ARM really needs to be an independent entity. If they don't want to, if SoftBank doesn't want to own them anymore, they need to find somebody who could own them and still be independent. For example, TSMC and ARM, I could see being a marriage made in heaven because they both only provide technology to a range of companies, and they don't compete with their customers. TSMC is very clear that it does not compete with any of its customers. Unlike, say, Samsung, who does. Samsung, makes chips, and they make phones, and they make everything that uses the chips. And so even people who want to use Samsung as a foundry are a little nervous because Samsung Foundry is not a completely different organization from Samsung, the microprocessor company, or Samsung, the cell phone company, or Samsung, the consumer electronics company.
So you're basically saying that the Chinese should get ARM. I'm joking. But
well, TSMC, which is not quite Chinese.
Yeah, okay.
Or maybe the UN can take it over. Who knows? But
I think, like we were just saying that the EU is saying they have issues and they want to have some sovereignty and stuff. And the EU should jump in and say, hey, we'll take it. We'll take care of it or something. I don't know how, but because the bureaucracy of the EU is not really super effective, but they could put on the money and say, hey, just keep running in there of where you were. I know that's not going to work. There was Brexit. I'm sorry, I forgot. Yeah. So I'm not totally sure what's the solution. Yeah.
That's above my pay grade.
But NVIDIA is awesome. NVIDIA is great, but it's just so weird when the U.S. goes around and blocks all the Chinese over the last 2-3 years. Blocks the biggest Chinese, the Huawei, and then they're supposed to just take ARM and then block it even more. I don't think China is going to agree to any of that, not even remotely.
Yeah, and no way can I defend what the U.S. is doing with Huawei. I think that's a huge strategic mistake. And hopefully the Biden administration will be a little bit more clear-headed in that regard, as opposed to the Trump group, which basically really was, trying to stick it to China.
Yeah, so there's another that you were on your LinkedIn talking about Pat arriving to his building. Mm-hmm. And right here, I saw something that you're talking about benchmarks for AI. There's this really interesting chip company called Nuvia It belongs to Qualcomm
Uh-huh.
now, right? Um,
Yes.
and it's maybe there's some other ARM chipsets that are really focused on accelerating the AI for the cloud, for the supercomputers and everything.
Well, I think the the entire shift to AI has created new opportunities for companies who are trying to optimize products that are good at either inferencing or training. And what we're doing with artificial intelligence these days is just mind-boggling. When I was at MIT in the 60s, I actually took a course on AI from Marvin Minsky, who was the father of all this stuff. And uh, so I've been interested in that for a long time. But, you know, until we came up with the deep neural networks and hardware optimized for the convolutions, AI really was not, was more of a curiosity than it was meaningful technology for solving real world problems. And that's just completely changed in the last decade. So, and as that's changed, then that's created opportunities for the Nuvias and so forth to go ahead and build machines that have specific features that make the AI software run better and more, you know, do more computations with less power in order to advance the state of the art. And that's going to keep going on. And I think we're just scratching the surface now in terms of what we can do with that. It's, again, as I say, mind-boggling.
And if I may put two things together, like this AMD benchmarks, one of the things you liked on the LinkedIn, and it's just AMD, just way in front of Intel. So AMD has been having a good strategy in the last 2-3 years, or?
Oh, AMD's had a phenomenal strategy. And, you know, it's one of these things where I think necessity is the mother of invention. So when AMD was planning its reentry into the high performance markets back in the 2015 era, 2014 era, they wanted to be able to build chips that could be used in servers as well as desktops and notebooks. And they didn't see an easy way to do that by creating lots of different chips. And so their first generation of the Zen generation, which came out, I think, in 2017, was designed so that they could use some of the chips that would go into their desktop and mobile processors and can put several of them together inside a single multi-chip package to create a server. And they really pioneered what today we regard as the chiplet approach. Lots of little chips inside a package, and so you lift up the cover and you see that it's not just one big chip, but lots of little chips. And in semiconductor manufacturing, you can make a lot of little chips to cover a given area of silicon a lot less expensively than one big chip that would provide the same number of transistors. And so they did that because they had to, but it turned out to be the right thing to do because it put them on a development arc where they now have up to 9 chips, I think is the last count, in their Rome processors to provide up to 64 processing cores and lots of I/O in a single server chip, where Intel, to get that kind of capability, needs to have one large chip, which is much more expensive to manufacture and doesn't cover the entire range as effectively. So that's given AMD a huge advantage in terms of performance and price performance compared with Intel. And Intel is still struggling, because of their problems with 10 nanometer, but also because of their monolithic large chip approach. And so Intel will, I think, change to chiplets. I mean, everybody else is doing it. It's been now pretty proven technology. But in the meantime, AMD is turning in benchmarks where, for the most part, except for some very narrow areas where one or two Intel architectural features can give Intel an advantage, for the broad set of cloud and high-performance computing tasks, AMD is just leaving Intel in the dust.
Nice, but the king, of course, the winner is going to be the ARM, right? When I look at this, there's a news. I'm joking, but a little bit. But when I look at the news right now, today, actually, I think it's like in a few hours they're gonna turn on the Fugaku, the world's biggest supercomputer, and it's ARM powered. And in Japan, they're gonna use it to calculate tsunamis and stuff, right? So this is also one way, and Amazon has been doing some really interesting stuff with they're doing a whole bunch of AWS instances on the ARM over the last year.
No, ARM is clearly making headroads in this area. The situation with Fujitsu to build that the ARM that goes into the all of the Japanese supercomputers now. Those used to be powered by Spark, and it must have been almost a decade ago that Fujitsu said, "Hey, we're going to do the next generations of these supercomputers on ARM." They actually added to the ARM architecture to embed many supercomputer kind of computational features that weren't in ARM before, and then they built these really monster chips to do it. And so, yes, for the last 18 months, when you look at the supercomputer rankings, there's the ARM-based chip from Fujitsu in at the top of the stack,
and it's just a huge jump. When I look at this thing, is nearly 3 times more powerful than the PowerPC #2.
Yeah.
And it's 5 times faster than the Chinese, which was the fastest when I was at Supercomputing 2017 in Denver. It was I think that was the fastest one, but that's now this one now is 5 times faster.
It's amazing, yes. And of course, one of the key elements here is, in order to get these kind of performance numbers, you need a lot of cores. And if you need a lot of cores, it's really helpful if each of those cores uses less power, because the challenge in exascale computing is how to get an exaflop without making the lights dim all over town. So ARM, I think, has demonstrated some real advantages in that regard compared with other architectures, although I don't think that it is only the ARM versus x86 that is making the difference there.
Yeah, this is my video from 2 or 3 years ago at the Lenara Connect 2018, when they were talking about their new ARM A64FX, the chip, because they of course very involved with the Linux on ARM to optimize everything for their chip, so it's ready, and it's kind of like launching today, as far as I understand. So that's happening. But there's so much news. There's been a lot of consolidation in this, not just NVIDIA trying to buy ARM, but a lot of giants buying other giants.
Oh, sure. For example, HP bought Cray, right? You still can buy a Cray supercomputer, but you're getting it from a salesman who's business card says Hewlett Packard Enterprise.
Well, so they were competitors.
They were competitors, yes. And so, the world continues. It's unlike the universe, which is continually expanding. We have the semiconductor and the systems world in which a small number of vendors continue to acquire all of the companies that are smaller than them. And so it's always an issue of you are either going to be the acquirer or the acquiree. And so I think in many boardrooms, people are looking around saying, hey, who can we buy? Or who do we have to worry about, defending ourselves when they want to buy us?
All right. And there's so many other topics to talk about. What do you like? I have one of your research papers, a recent one. So what is this? What do you say in this one?
Well, there's a trend in enterprise computing these days called hyper-converged infrastructure. I don't know if you've come across that in any of your other interviews, but it's basically a way of being able to use a small number of computer systems to provide aggregated performance and ease of management. The real challenge that a lot of data centers have these days is how do they manage all the machines and distribute workloads and so forth. And hyper-converged infrastructures are a good technique to simplify that. And as a result, it's still a relatively niche market today. But if you're talking to IT departments, if they're not considering or looking at HCI, then they probably should.
And this is in partnership with AMD. You did this one. So are you talking about the EPYC AMD taking over some of the Intel Xeon stuff?
Well, AMD certainly is hoping that the advantages that they bring to the server market in general can be exploited successfully by companies who are selling these hyper-converged appliances, companies like Nutanix, VMware, and such. And they've been working with those software suppliers to optimize the features that are in each generation of EPYC to improve the value proposition for HCI. In fact, just talking to them recently, they're planning to come out with their next generation server processors, which are known by the code name Milan. Got an email this morning saying they're going to make an announcement about that next week. And they are hoping that with Milan, they will be able to compete across the board with Intel in terms of delivering superior price performance, superior performance per watt, more scalability, and those are all things that go into hyper-converged infrastructures. So we will see whether or not they can convince their OEM customers, the HPs and so forth. Dell's very big in hyper-converged environments because Dell owns a big share of VMware, and VMware is huge in hyper-converged environments. So AMD, who's always had a very strong relationship with HP. Did I say that right? AMD has had a strong relationship with HP, and AMD also now, for the last few years, has had a pretty strong relationship with Dell. So they're hoping that these new Milan generations can flow into those companies' server lines, and in particular, those companies' hyper-converged infrastructure optimized servers.
All
So
right.
that could be a big game changer, since right now Intel has like 99% of the HCI market.
All right. It's not an alarm about the end of our interview, no? I hope. No,
No,
no. It's just the time. You have.
no, I like to say that I share my office with a clock store, and so anybody who's on any kind of calls with me usually hears chimes going off all the time.
Are there Swiss cuckoo watch?
No, most of these are German movements, as a matter of fact.
All right. But the Swiss movement is the best, right? I'm joking. No, okay, no, because I'm Swiss, so no, I'm okay. But there's. So maybe you can talk a little bit about like how many different like research documents do you have like all kinds of things planned out, or you published stuff before about all kinds of different topics recently?
Well, I have, being an independent consultant, I have a lot of options in terms of how I spend my time. And at this point in my life, I'm actually spending less and less time worrying about semiconductors and more time worrying about where I should go on my next trip when we finally get back to some sort of normality. And hey, I've had both of my vaccinations. So according to the CDC this morning, I'm actually in pretty good shape. I can go and see grandchildren or whatever. But I do, because I find the industry so intellectually stimulating, I do keep track of what's going on. But in terms of actual gigs for to monetize my knowledge, that's becoming less of a priority for me these days.
All right. So basically now you can go to the supermarket without wearing a mask.
Hey, yes. Although I just got a new mask, I don't have it here, that has an embedded LED display that you can program.
Nice. You can have it say, "I'm vaccinated."
That's exactly what I'm going to do.
All right. So that would be you can sell advertising space.
This space for sale.
I wonder what the NVIDIA what the Nuvia is gonna add to Qualcomm, because there was, as I understood, it was like in the servers, but it sounds like it could also be like helping Qualcomm make better chips for laptops and desktops. Because that's the thing that I've been hoping for. Now with the M1, it's such a. I'm using the MacBook M1 right here, and so far I'm not crashing. I mean, I'm crashing every day a little bit, of course, but that's more because of the Mac OS.
The challenge, I think, for the M1 is being able to run Mac applications that have not yet been ported and optimized for the ARM environment. And I think that's going to continue to be a challenge until that conversion is through. And similarly, Qualcomm has been trying to convince people that an ARM-based PC running Windows 10 is a good choice. And there, I think it's even more problematic that you will be able to run the entire repertoire of Windows applications successfully. So I think there's still an emulation problem that is going to exist for a while.
For example, right now I'm in Chrome on my MacBook M1, but I'm experiencing bugs every day, pretty much, like a bunch of weird stuff, like the video doesn't show up, or I have to go over to Safari to see something. A little bit weird, and that's with a Chrome that's supposed to be already optimized for the ARM. And then when I use my Windows 10 on ARM Qualcomm laptop, there's no Chrome, of course. So the only Chrome that I can do is the one that I have to emulate from x86. There's not even a real Chrome yet. There's only Edge. or Firefox. So there's some, and I'm not even starting to talk about getting support for all the Adobe apps or something like that. That's not even started on Windows. Supposedly, there's some beta, and it's going to eventually maybe happen on this M1. Hopefully, now that's the very positive thing, is that Apple has a tendency of pushing people around in the way that they want, right? And they're definitely going ARM forever. So they're gonna push these. They have trillions of dollars in the Swiss bank account, right, or Irish bank account. So they could encourage people to port all their apps now.
Or the U.S. government could just seize all those trillions of dollars, and that would help pay off some of our national debt.
Yeah, they should just take the Apple money to pay for the $1.9 trillion stimulus.
Hey, Jim Cook, pay your share. Yes.
Yeah, yeah. I think that would be fair. That would be great. Yeah. So there's always this kind of talk also sometimes that. Well, this is just a patent dispute, but usually there's all these other things where that's again in politics, where the different governments are going after big tech in some kind of way, trying to put some slowdown.
Yeah, but in that Intel situation, this was a company that bought some obscure patents that Intel was infringing on, and then they brought a suit and they pursued that infringement for a while. And the most recent thing coming out of this West Texas District Court, which is known to be a very patent troll friendly court, came out with a ruling. What is it? 2.6 billion or some humongous number. I've never been a real fan of companies that buy up intellectual property and then pursue people who are violating them. And in general, when somebody comes to me and says, "Hey, Nathan, how would you like to be an expert witness for us? We're suing Intel to do, because we think that they're violating our patents." In general, I say, I'd rather not. I don't really like that particular business model. But, some people do, and every once in a while, they win either in court or they get a settlement out of court. So, the nice thing about the semiconductor business in general is there are lots of different ways to make money. And you can make money by inventing things. You can make money by selling your inventions to other people who can then utilize them. And hey, whatever works for you. But again, often in the case like this particular one with Intel, my guess is, and I have not looked at it in detail, Intel designed their chip using features that were either generally known at the time or that their engineers came up with independently, and they accidentally wandered into an area where somebody already had a patent. And, you can't research all of the patents or how a particular design could infringe on everybody's patents, because that would slow your design cycles out tremendously. And so what you do is you design so that you don't think you're infringing anybody, and every once in a while it turns out you did. As a matter of fact, Intel, as a result of that exposure, often tries to achieve or enter into what they call cross-licensing agreements with anybody any other manufacturer who might have intellectual property. So, for example, Intel and AMD have a patent cross-licensing agreement. at the various times they've had big battles over what was covered in that. But because they do have those cross-license agreements, that means that for the most part, if AMD came up with a really clever circuit trick in one of their products and they patented it, and Intel independently or even dependently used the same trick, then neither company can sue the other. And Intel calls that design freedom, because they don't have to worry as much about infringing other intellectual property. They've had those agreements with most of their customers and many of their competitors, Qualcomm and so forth, for years. And the only problem that people who try to have those cross-license agreements to cover them encounter is when somebody who doesn't actually make products and doesn't need any of your patents or doesn't have to worry about infringing your patents comes along and that you discover they're infringing one. So that's when the intellectual property owners who are not manufacturers can, in fact, challenge Intel and sometimes win in court.
All right. And this was more in the consolidation area, the Xilinx, $35 billion. The AMD just has, I guess, because they're a little bit successful, the stock grows like crazy over the last 3, 4, 5 years. And it's a little bit the same thing that happened with NVIDIA. They went from being valued at 30 or something billion to 300 billion or something like that. And that's how they can just start to suggest that they want to buy ARM. And now AMD is talking about buying Xilinx. I wonder if they will take these FPGAs and put them in some of these future AMD chips.
Oh, I think clearly they will. I'm not sure if that deal has been approved yet by all parties. But unlike the situation with NVIDIA and ARM, if AMD were to acquire Xilinx, I don't think that any of Xilinx's current customers would worry about AMD tilting the Xilinx roadmaps in ways that would be, what's the right word? That would disadvantage them with regard to Xilinx's other customers. And so from that standpoint, that makes sense. And there are a couple of things that are going for that acquisition. One is that Xilinx is a big player in the 5G infrastructure market. FPGAs play a big role in 5G infrastructure in general because you have very critical real-time performance requirements and the standards are always in flux. So you want to, instead of building an ASIC to do switching, say for a 5G base station, you throw in an FPGA, and that way, as the standards evolve, you can just download a new code. So FPGAs have always played a big role in 3G, 4G, and 5G infrastructure. AMD had no exposure, basically, to the 5G market. And so buying this gives them access to all the guys who are deploying 5G infrastructure, base stations in particular.
All right. If you don't mind, I just opened this interesting, funny article. It says 2021 will be calmer year for semiconductors, except for Intel. That's kind of like a funny title, no?
Yeah.
I guess they talk about consolidation.
Hey, as much as we want to say, boy, Intel's really in trouble, the fact of the matter is their factories are all running at 100% capacity. They're still, their customers are begging for more. And so, yeah, people can say, oh, yeah, they've really screwed up on, 10 nanometers, 7 nanometers. Intel's doing okay. The money is flowing in, and at an alarming rate. every quarter seems to be bigger than the previous quarter. And so even though they're struggling with some leading edge technology, their customers are still buying, and that's really the crucial thing. So I think even Intel is going to have a good year in 2021.
Nice. So you're looking forward to a network with all these guys again over there in the Silicon Valley? Where are you based?
I'm in Silicon Valley. I'm in a little bedroom town called Saratoga that's just on the western fringe of San Jose, Silicon Valley. And, you know, I run into some of these people in the supermarket. So,
do you know all these guys that invented all this stuff? Did you meet them in the last 22 years?
Well, I would say that I know all of the people who are in the analyst community. As a matter of fact, I was on a call this morning with a number of analysts, and we all recognize each other's voices. We all sort of know, well, here David's about to talk. He's going to give us some sort of really erudite, very techie kind of question and so forth.
Nice. Do you publish those analyst calls?
No. As a matter of fact, these analyst calls are basically done on an NDA basis to alert us when some new important developments are popping. So there's stuff I know today that I can't tell you about.
Nice. It's exciting every day what happens. And this year is going to be a fun year.
This year is going to be a fun year, and hopefully, knock on wood, we will get back to a situation closer to normalcy, and it couldn't happen soon enough.
And meet at the Santa Clara Convention Center for something.
Yeah. Well, you know, every one of what they've done is they've repurposed so many of these convention centers to be massive vaccination centers.
Yeah. All right.
Okay. Good talking to you again.
Thank you so much. Thanks for an overview, and so we can understand all the stuff that's happening. There's so much stuff happening. It's huge.
Thanks
a lot.
Very good. Look forward to doing it again sometime.
Thanks a lot.
Bye-bye.
Yeah, and thanks everybody for watching.